All right. So now we're jumping to a whole different subject. It's called linear inequalities. Now, the way we approach them is going to be different, but essentially how we work them is exactly like an equation, except this is said differently. So remember when we were talking about equations, it's because things equal. This obviously does not equal because it's called an inequality. But let's start taking a look at some of what makes all this up, and hopefully it starts making sense. There's a lot of videos I sent regarding this, so you can get a lot of exposure to it. This will also help you be stronger with equations, with graphing lines. So make sure you watch all those videos because it really is going to help you understand this a lot better and from different perspectives. So first, what we're going to talk about is what we call interval notation. Okay, so there's a language of how we report or write down these inequalities, and it starts with the interval notation. So with the interval notation, we're going to set up a parentheses. The first number is going to be the start, the last number is going to be the end. Now, keep in mind that we're going to be using infinity a lot and negative infinity. So infinity goes both ways. So we work with infinity a lot. So we use parentheses, and then we'll put numbers in there. For right now, you can see down there at the bottom, to represent all numbers, we put parentheses, negative infinity, comma, infinity. And that's kind of the standard of how we will start reporting things. And we're going to show you a couple of different ways to engage in that because it'll mean something different. But just for now, your basic interval notation will be parentheses, a number, comma, a number, parentheses. So when we do this, we're going to be using a number line. So we're going to start off with this example of x is greater than or equal to 1. Now, if you need a refresher on greater than or equal to, please let me know, or feel free to look up a video. There might be a couple of videos that I sent over that kind of cover it, but it's a very integral concept to what we're going to be doing on this. So let's just take a look at x is greater than or equal to 1. And let's start off just by thinking about that. What does that mean? X is greater than or equal to 1. Okay, so that means x is a number bigger than 1 or equal to 1. So that means it could be 1. All right, so 1 and then all the numbers on a number line to the right. So we would go ahead and write that in an interval notation as bracket. So bracket means including. So that's why we would do it in this case instead of the parentheses. So we would write bracket 1, comma, infinity. And what that would, if we were to read that, it would be the numbers including 1 and greater. And we can see down here on a number line, we can even put it on a number line. All the numbers to the right, because all the numbers to the right are greater than 1. Now, in this case, they're using the bracket on the number line to indicate we're including 1. The way I like to see it, because it's just the way I was taught, is with the circle. So an open circle means it does not include 1. Closed circle means it does include 1. So just two different ways of saying the same thing. So this is really where we start getting to inequalities. So in this case, it's -2 is less than x. And remember, x just stands for like we don't know, or it can be multiple things. X is just there. And x is less than or equal to 3. So like, let's start off by just trying to think about this. Okay, -2 is less than x. Okay, so that means kind of like on a bookend, like the minimum is going to be -2. All right, because -2 is less than x. And then x itself is less than or equal to 3. So in interval notation, we would write that as parentheses, because it doesn't include -2, -2, comma, 3, because x is less than 3, so that's the other bookend. But this one could include 3, so then we're going to do bracket. And if we can see how that represents on the number line. So x is essentially any number between -2 and 3, possibly including 3. And when we start getting to working the mathematics of this out, you could pick any one of those numbers and it should work out. But this right now, we're just kind of focusing on the language, like how we would say these things. So a linear inequality, just like an equation, so if you think of the word equation, it equals, linear equality does not equal. All right, so we can't, it could, but really what that greater than less than sign means it's not equal. So y plus 8 is less than 2. That means y somehow makes 8 less than 2. And we can kind of think about what that would be. So like maybe y is -7, because -7 plus 8 would be 1. So that's a valid number. If we look at the second example where m minus 4 is greater than or equal than 10, so what would m have to be greater than or equal to 10? So 14 minus 4 is equal to 10. So 14 would be a valid. And then 7x plus 2 is less than or equal to -9. So we would think about the values that are less than -9. So, and I'm just trying to think this off my head. I would say probably if we can throw in like -10, which would be -70 plus 2, which would be -68, which is less than -9. So you can see, but there's a bunch of different options in there to engage in. And that's why can we use the interval notation, because we're not saying in an equation, we would say, like x equals 8. In a inequality, there's a set of numbers that could qualify. And that's why we use the interval notation to express that. So we use what's called the addition property to do this. So solving an inequality finds all the numbers and make it true, like I said, as a set. Usually there's an infinite number of solutions, but not in that case where we kind of had like the bookends. So it wasn't infinite. It was actually bookend on each side, but it can be infinite. And that's what so if we think about like x is less than 2, well, all those numbers heading to the left of 2 forever and ever are going to be solutions to whatever problem that we encounter there mathematically. So we're going to work these exactly as we would with an equation. We're going to isolate x to one side. So in this first example of x minus 5 is greater than -9. Now, I think that's one of the ones we took a look at earlier, and I was kind of just guessing and testing. But again, we want to get the set of numbers. So that's why we want to do the math on it. So we want to get x by itself. And just like an equation, Whatever we do to one side, we just have to make sure to do it to the other. Now we want to get x by itself, and we have this -5. So the opposite of subtraction is addition. So we're going to add 5 to both sides. -5 plus 5 zero each other out. We're left with x, which is exactly what we wanted. We have to do it to the other side. -9 plus 5 is going to give us -4. So x is greater than -4. Awesome, we solved it. And we can double check it. So if we put in -4 for x, we actually get -4 plus -4, which equals -9. -9 equals -9. So x is true. The problem with this, though, is that -4, -5, it works in this statement. So we made it equal. We made it an equation. And that's just having a little issue. I didn't transfer my signs over. In this case, we were testing it by making an equation. So it does make it true. The thing that I was looking at was that there was that it's greater than, but not equal. But we can turn it into an equation just to test it out. And -9 equals -9. So that kind of passes the test. So in this case, what we would do to graph is we would test numbers on each side. And that's kind of what I was looking at more, not so much the equals. But if we said -9 or -8 is greater than -9, that is true. So -3 is in the solution set. So we replaced x with -3. If we tried replacing x with -5, well, -5 and -5 add up to -10, and -10 is less than -9 because it's smaller going left. So -5 is not in the solution set. So when you graph, you would keep that in mind. All right. So let's go ahead and try working on this one. And I'm just going to go ahead over here. I'm going to make a little thing here. I'm going to try not to write because my handwriting's bad enough, but then trying to write on a screen. I don't know how like Khan Academy guy does that. He writes really well. That's not me. So we have 3 plus 7m. Now in this case, m, because we've been talking about how like m is slope. In this case, m is just a variable. So when we talk about like equations and inequalities, normally we use x, y, z. We can technically use any letter. In a live class, I've actually used stickers, so it'd be like 3 plus 7 unicorn. In this case, m doesn't stand for slope, it's just a variable. So the thing we don't know. And that's going to be 8m. And so we're just going to go ahead and carry the or equals 2. I don't know if it'll let me do it. No, it won't let me do it on there. So just remember that it's also 2 or equals 2. I just can't get it written on here. So we want to get m by itself. We're solving for m. Unfortunately, this one's a little more complicated than some of the stuff that we have looked at because m is on both sides. Still not an issue. So basically, we're going to pick a side to throw m over to. Just through experience, I know if I bring that 8m over, I'm going to have to throw the 3 to the other side. That's 2 steps. I don't want to do it. So let's just get the 7 over to one side because then it's less of a step to do. So remember, we can do anything we want. We just have to do it at both sides. So to get rid of that 7m, I'm going to subtract 7m's. I just have to do it from both sides. So if I subtract 7m's, so 3 we just leave alone. We're not doing anything with that. 7m minus 7m is going to be 0, which is awesome. So we got rid of the m on one side. But then if we're subtracting 7m from 8m, we're left with an m. And look at that. M, 3 is greater than m. Now remember, because just I didn't have anything on here that allowed me to move the greater than, so just remember that this was 3 is greater than or equal to m. And that's our solution. And then we would graph that. So to graph it, on this one, I would probably have to use a number line of some kind. So let's just remember that this is, ooh, that's thick. Let's see if we can find a thinner one. Or not. We'll be okay. So we draw our number line. So 3 is bigger than m. So whatever m is. Or actually, in this case, because it's on the other side, 3 is bigger than or less than m. So let's go ahead and do that one. 2, that's my angry little dog in the background. That's 3. And so since this includes, we will go ahead and do a solid circle. And remember, m is less than, because 3 is greater than. So it's going to be m is going to be all the numbers to the left. We usually do an arrow of some type. All right. And I know it's a little hard to read on there. I don't have all the fancy Khan Academy type equipment. I just have the angry little dog in the background. So let's take a look at a couple more things. Let's see if I can erase everything. Or not. Yeah. Boom. Boom, boom. All right, we got that erased. We're good. We're good. We're good. So let's take a look at another problem. Just want to make sure it didn't. So in this case, we are going, now we have 3m is greater than or equal to negative 24. So remember, we'll want to isolate m by itself. So we want to get rid of that 3m. We will actually the 3, so away from the m, so that we can get the m by itself. So 3 times m, the opposite of that would be division. So we're going to divide by 3. And 3m divided by 3 leaves us with our m. But since we did it on one side, we have to do the other side. So we're going to divide negative 24 by 3, which gives us negative 8. So m is greater than negative 8. So it's very similar to what we did before. On this case, we would just have a number line. We would do negative 8. And since it's greater than or equal to negative 8, we put a closed dot. And then we would do the arrow all the way to the right forever and ever, because we're talking about all numbers greater than negative 8. So the multiplication property of inequality is that when we test these numbers on the side of negative 8 to verify, we want to choose numbers that make the inequality true. So let's take a look. And essentially when we do that is, what we're going to do in a very practical way is that when we choose an opposite operation, if it has a negative, if we're multiplying or dividing by a negative, we're going to flip our inequality symbol. So the inequality symbol is the greater than or lesser than symbol. And that's because in multiplication and division, we're almost changing the truth of everything. So we need to change the sign to maintain the truth of our statement. Let's either trust me or not trust me on that one. But let's take a look at an example of how that works. So here we're going to start off with negative 7k is greater than or equal to 35. Now, again, we want to isolate k because we're trying to solve for k. And so we're going to negative 7 times k, the opposite of multiplication is division. So we're going to divide both sides by negative 7. And so on the k side, we end up with k. But because we divided by a negative number, we're going to flip the greater than sign because now it's a less than sign to make the statement true. We're going to keep the equal to, but we're just going to flip that sign. And then we're going to continue on because we divided one side by negative 7. We're going to divide the other side by negative 7. And 35 divided by negative 7 is negative 5. Now which is true. So like k is less than negative 5. If we didn't flip that sign, it would still read k is greater than negative 5, even though we're dealing with this negatives. And remember, negatives are less than 0. So in order to maintain the truth of our statement is why we're flipping in division and multiplication, or division for the linear inequalities. Again, I'm gonna reiterate to you that I sent you a bunch of videos to watch those, because this isn't pick it up in one step. A lot of the stuff that we're going to be doing in this class is not you're going to hear it once and you have mastered it. It's going to be hearing it several times, and it's going to be working on those homework problems so that you can get a better idea. So here we're looking at solving a linear inequality, and you can see that it got bigger. And so that's what's going to happen. And this is not a problem. And this will be good that if you do need a refresher on the distributive property, this is going to show it. So we have this negative 5 times x plus 3 plus 7 is greater than 14 minus x. So this does get complicated because we have this distribution we need to do. We have x on both sides, but it's still doable. And so we're going to start off by distributing things so we can see things clearly and all spread out. And what that means is the parentheses here mean multiplication. So what we're going to do is we're going to multiply this negative 5 by each of the items inside the parentheses. So negative 5 times x is negative 5x. Negative 5 plus 3, positive 3 times positive 3 is going to be negative 15. We're just going to carry that 7 down. It still stays greater than or equal to 14 minus x. Now, what we're going to do now is we can go ahead and combine the negative 15 and 7 to kind of make things a little smaller, a little easier to read. So negative 15 plus 7 is negative 8. So now we got it down to negative 5x minus 8 is greater than or equal to 14 minus x. So now we just need to get the x all to one side. In this case, let's get rid of the x on the right-hand side. So to do that, since it's negative x, the opposite of the minus is positive. We're going to add x to both sides that we can see down here in step 2. So if we add x over here on the left-hand side, we just kind of add the x, but really we're going to add that x to negative 5x, which makes it a negative 4x, because negative 5 plus 1, negative 4x. Over here on the right-hand side, the x's are just going to cancel out each other because it's negative x plus x. So now we have it down to negative 4x minus 4 is greater than or equal to 14. So let's get that whole number, negative 8, over to the other side. Opposite of negative is positive. We're going to add 8 to both sides. On the left-hand side, negative 8 plus 8, 0 each other out. On the right-hand side, 14 plus 8 is going to be 22. And so now we have it down to negative 4x is greater than 22, greater than or equal to 22. We are almost there. So we want to get that x by itself. So negative 4x is negative 4 times x. So the opposite of multiplication is division. So we're going to divide both sides by negative 4. And when we do that, our x gets isolated by itself because it gets canceled out. But remember, when we divide by a negative number, we flip the sign because division is making a number smaller. So it's going to make our sign untrue if we don't flip that sign. And then 22 divided by negative 4 is going to be, and remember we talked about, we're going to put it as a fraction as 22 over 4. Talked about, like, yes, there's usually better numbers to try to reduce a number by, but since they're both even, we're just going to do 2. And so 2 goes into 22 11 times, 2 goes into 4 2 times, which is about as small as we can get it to. So that gives us our answer. X is less than or equal to negative 11 halves. And then so as an interval set, to cover all those, we would do parentheses, negative infinity, because all we're doing less than. So we want all the numbers that are smaller than 11 half, comma, negative 11 halves, bracket, because we just said including. And then we can graph that as, again, I prefer a closed circle, all the numbers less than, everything to the left, negative 11 halves. And negative 11 halves is like negative 5.5. That is a lot to take in. I know. And that's how come I want you to work at these and watch the other videos and do the homework and even make mistakes, because it takes work. You're now in a level of math that requires work. It's not as simple as 1 + 1 or 3 + 5. Now there's going to be multiple steps. And so we're going to take a look at this beast. And this one just looks a lot more complicated because it has the fractions. But we're just going to follow the steps because that's going to lead us to the answers that we want and need. So we're here with negative 2 over 5 times r minus 5 minus 1/3 is greater than 1/3 times 7 minus r. Take your breath, relax. We got this. It's going to be a little messy, but it's doable. And so let's start off with the whole. In this case, what they're doing is they're multiplying each side by a common denominator. Totally legit. Remember, what we do to one side, we can do to the other. Now, this is not something that I expect you at this point to be able to think of, but this is definitely a very helpful technique. And we're going to go through it just so you can get it introduced to you. But to be truthful, you're probably going to be doing things the longer way for a while until you get the experience of doing this. A lot of math is experience, and so it takes like years and years to be comfortable doing something or to just see in numbers to do one of these techniques. But I do want you to get exposed to it, because if you can get the hang of it, it makes life easy. And so we can do to one side anything we want as long as we do it to the other. And so we're going to multiply both sides by 15. And what happens here is it does change the numbers a bit, but it sets up the 15 so that we can go ahead and cancel out the fractions. So we go ahead and we multiply by 15. We go ahead and we do our distributive property. So the negative 2/5 times r, negative 2/5 times negative 5. And that's where a lot of the magic is happening, because remember, if we take a whole number, we can put it over 1. Those 2 5s actually cancel out with each other. Here we have our negative 15 times 1/3 because we're distributing everything out. And this is actually something that I would probably want to go over with you in class so we can go through all the mechanics. So I'm going to kind of skip ahead here. I do want you to become familiar with this, but we're going to go over this one in class so we can go over step by step and you can see me do it. I just don't have my mathing camera up at the moment. So same thing, we're going distributed property, adding 5R, subtracting 25, working through this step by step, and that's how we get it. And finally, we get it small enough. We're multiplying -1, so we're going to change the sign. And eventually we end up with this R is less than -10. I'm going to make a note that this is something we're going to work on in class, because it is kind of big and ugly and a little unruly to do in this format. So we'll probably go over this on Monday. All right, and so just a couple of more things here and we'll wrap this video up. So this was a lot, and so I'm going to throw more on you. Sometimes we have that X in the middle. And so we have to solve for X, as X is when we have statements on both sides. And essentially what you're going to do is you're going to move that -2 over. So we're still trying to isolate X. But in this case now, what you do to the middle, we have to do to both sides. So still the same concept. If we have 3 parts. What we do to one part, we have to do to both parts. And so if we take a look at the bottom, we start off with 3 is less than or equal to X minus 2, less than or equal to 7. All right. Now, what we do to one part, we're going to do to both parts. And I want to get X by itself. It's -2. The opposite of -2 is +2. So I'm going to add 2 to all 3 parts. In this case, 3 plus 2 is 5. In the middle, the 2's cancel out. So I got X by itself. And on the right-hand side, 7 plus 2 is 9. So now our statement and our final answer is 5 is less than or equal to X, which is less than or equal to 9. And so we're just still the same concept. We're just applying it to 3 parts instead of 2. So again, this is a lot to take in. This is a huge step in your math journey. Watch the videos I sent you. Take a look at some of the homework questions that you have to work on. And we'll revisit this a little bit on Monday's class. And hopefully it starts making little sense in little pieces. All right. Thank you very much.